Hello everybody, Aber here once again, and we have a new helicopter. To apologize to Pook Nukem, your helicopter was not cutting it, and Word Andrew was very upset that I was not using his helicopter. So here we have Word's helicopter, and I've got a brand new brain that I built from scratch here. And I hope you guys enjoy this. But this is the helicopter with a chase camera. Alright. Word Andrew plus ST Abra style. This, probably the biggest difference between this is that this helicopter does not use move, it uses push. Because let's face it, let's be honest, push rocks. So yeah, oh, and here's what happens when you go backwards. There's still some adjustments that need to be done with the camera and oops. And yeah, and the helicopter. So this is not final, but I know some people screamed at me for not showing code before. So again, I don't recommend using this code just yet. Oh, whoops, I didn't move the chase camera over. But yeah, you can see the chase camera is actually completely unattached. Alright. The idea behind this is that the only thing you'll ever have to do is just you set the target equals, and then you select the object, and then you've got some variables here: desired distance, a height, and max distance, right? But I'm gonna add a min distance one as well, and I really there's a lot more work that has to go into this, but you wanted to see the code. Here it is for the chase camera. Okay. This one I did manage to get it working with the first-person camera, so this will eliminate a lot of future problems, but it was tough. Alright, the key thing is you can't actually use move. You've got to be manually setting your position with stuff like this, position equals position plus direction multiplied by camera speed, right? And, these other fun things. Alright, so this is where the position is actually getting set, but you can't use move, right? Like you have to manually calculate it out, otherwise you get this jittery stutter. So yeah, that's what that's doing. And then instead of to make the camera actually look at the target, right? This is the code to make it look at the target, right? Which is just this is simpler, right? Just up equals world up, and then forward equals target position minus position, right? And that makes the first-person camera actually look at a particular target, right? If you don't have this up equals world up before you do it, then the camera will it'll roll, and it'll get all twisted, and it'll be bad. Right? So yeah, so there's the current incarnation of the camera, but I do have a lot more tweaks and work that I want to do on it. So and then for the helicopter itself, the helicopter's ironically not that complicated. It looks really good, but currently you've just got your throttle here, which is equal to right stick multiplied by 1.5. And then basically you're just pushing up, right? Pushing up, strength, throttle, right? And then I've got some code here to give it like a max height, so you can't actually like travel too high. Excuse me. And then there's your yaw is equal to right stick X multiplied by 2, right? It allows you to turn. Your pitch, all right, and then your roll. Okay, I mean, but the key thing is that push statement before, because you're just pushing behind you. But then the problem is you don't actually, you basically reach the height, and then when you angle yourself, it really doesn't push you forward very much, right? And it does a tiny bit, but not enough to make it, good. So that's what this is here. All right, basically you set your movement direction. Yeah, because basically it takes the up vector, right, and then it removes the y component to that, so it's no longer pushing you up. It's pushing you in the direction that you need to be moving, right? Depending on where your propellers are kind of tilted. And then how fast you're going to be moving along that is going to be the movement direction length. This is going to be like how much you're tilted. Whether you're tilted just a little bit, you're not going to move very fast forward. But if you tilt a lot, then yeah, you are. And then here, and then after I check that length, I normalize it, and then this is the actual code, right? Pushing direction that, and then strength is speed. So speed is a factor, and then also, how much you're angled, I should say, is a factor, and then your throttle is also a factor. So yeah. And then this is also another thing. This is just setting the max speed. I've got a max speed set up at the top of, I think I've got it like 30 at this point, something like that. So if the velocity length is greater than max speed, then I just set the velocity equal to be max speed. So you can't go just ridiculously fast. So yeah, so that's the code for this. Yeah, and so the end result of all this programming code is this here. Our fun little helicopter. Oh, hey Milo. How's it going? I'm just recording a video here that I'm going to be posting on YouTube for Project Sparkers to enjoy. Because it's a lot of work programming all this. So yeah, and this is the helicopter. So I hope Wart, I'm sure, is going to enjoy this because it's his helicopter now, so he won't be mad. Alright, I'm going to end the broadcast now because that's pretty much all there is to it at this point. So, hope you guys enjoyed this. I'll see you next time.